Hello everyone, this is the solution of today's problem B, Nezzar and lucky number. So this was a tricky problem in the sense that the brute force solution works here. Like if you see the constraint, so you'll see that it should not work but it's working. And I'm just going to tell you why it's working. First, I'm going to discuss my brute force solution. Like this is the code I wrote, basically. Not wrote, I mean the code I wrote. Okay, so the question I think is clear to everyone that I'm just going to discuss the question. Let's just discuss the question first. Key, we have a number. Let's call a positive lucky number if d occurs at least once in its decimal representation. So we can, let's suppose um, we can call 256 lucky because let's suppose if d is equal to 5 because d occurs in this number. Similarly, we can call 913 lucky if d is equal to 9 and 9 occurs in this number. So what we have to do is we have to tell if I can break n into some lucky numbers. Let's suppose k lucky numbers. Up k can be 1, k can be anything. I just have to say, just have to tell basically if I can distribute n into k lucky numbers. Now let's just discuss the brute force solution for this. Yeah, so cool. So if d is equal to 1, so we can always distribute, because let's suppose if d is equal to 300, so we can distribute 1 300 times, right? If d is equal to, no, what I want to say is, let's suppose if d is equal to 1 and the number is 300, so I can always distribute 300 into 300 times 1, right? 1 300 times, so d is equal to 1 is always yes. That's the first condition, right? After this, what I'm doing is I'm initializing a variable j which is less than or equal to ai. I'm initializing j with d. D is our lucky, our basically positive integer, and I'm incrementing j with d. So what I'm doing is I'm starting a number. Let's suppose with j is equal to d, and I'm incrementing j with d. So j will become 2d, j will become 3d, and j will become 4d. So this I can always distribute into d's. I can distribute 4d's into 4d's, right? Now I just have to check if my number minus j, matlab this I can always distribute now. So I just have to check if my number minus j is a lucky number. So for example, let's suppose I take 38 and d is equal to 7. So I know that 7 I can always distribute. So first I will check 38. 38 is lucky number? No. 7 does not occur in 38, so it's not a lucky number. No. Now I'll basically make a variable j. I'm initializing this with d. So d is equal to 7. Now I'll check 38 minus j is equal to is a lucky number. 31 is a lucky number? No, it's not. Now I'll basically continue this process. So j is equal to d, j will become 2d. Now I'll check if 38 minus 14, 24 is a lucky number. No, it's not. Similarly 21, so this will become 17. Right, now 17 is a lucky number. So I'll basically simply print yes and break from the loop. Now a very good observation here is that this loop will only work around 10 to 11 times. And I'm just going to show you why. This loop will always run 10 to 11 times. Right? I'm just going to show you why. Let's suppose. So what I'm basically trying to tell you guys is key for number, if number is greater than 10d, d is our positive integer, obviously. So if number is greater than 10d, it's always yes. Yeah, if number is greater than 10d, it's always yes. I should have said this in the starting of the video, but nevertheless, let's suppose d is equal to 7 and the number is 91. Since I have the whole 70 wala line, 70, 71, 72, right? So I can set this accordingly. Let's suppose, So yeah, so I can always set this accordingly. Let's suppose my number was 1000, so I can make sure I can, I can take a lot of 7 multiples of 7. I'll decrement 1000 by subtracting it for 7, and when I reach the 70 wala line now, so since I have the whole 70 line to me, right? It's I've have if I have the whole 70 line to me, so I can always let's suppose if the number ends at 78, so 78 is a lucky number. If the number ends at 77, so 77 is a lucky number. That's what I want to say. For d greater than equal to 10d, it's always yes. So the solution, which is looking brute force, is actually going to work only 10 times max. It's not going to work more than 10 11 times. I'm not sure about 10 11, but it will work very less. It will, the loop will run very less number of times. I've also proven it here. Like, I've taken a lot of big numbers, but the answer is always less than 10. It could be 11 in some cases, but I don't know. So the question, so the observation is key, if d is less than 10d, if number is less than 10d, then only this question makes sense. If our number is greater than equal to 10d, then simply see out yes, or if it's less than 10d, then we have to basically brute force check at most 10 number of times. So yeah, that was the question. If you have any doubts still, you can just post down anything you want to say in the comments, and I'll make sure to reach out to you. Okay, thank you.